Welcome to the Petroskills Completions and Workovers series. I'm Kyle Travis. Today we're going to be talking about workovers and specifically workover planning. So as this says, one of the first things you have to realize is you need to have an open mind when you're planning a workover. You don't want to have any preconceived idea as to what needs to be done, so that you can do a good job of figuring out the problem and designing a solution. One thing that you need to do before the workover is deciding what is a successful or what constitutes a success or a failure. So define that ahead of time when you're more objective. If you wait till afterwards, you're going to maybe be less objective. Also, this techno-economic process is absolutely crucial to workover planning. And I contend that there's no one in your company better suited to perform the techno-economic screening process than an engineer. Engineers have an understanding of the technical, of the equipment, of the reservoir, of the well construction, but they also have a good handle on economics. So really, engineers are best suited for this process. I encourage all my students to document and leave a good audit trail, not only what was done, what was put in the hole, why it was done, and what was learned afterwards. An investment of time and planning greatly influences the achievement of success or failure in the job. As my grandmother and mother used to tell me, an ounce of prevention is worth a pound of cure. So the more effort you put into the research and the planning, then you're going to get better results. Things don't always work as according to plan, so we always want to build contingencies into our workovers as well. There are a lot of unknowns usually associated with workovers, so we have to build in some flexibility when things don't go the way we anticipate. After the job is done, we always want to review the process, see what was done, was it successful, what we learned from it, what we're going to take to the next one, and improve upon that. And as I like to say, we learn as much from our failures as we do from our successes. So failures aren't entirely bad as long as we learn a good lesson. But you want to have more successes than failures, or they may not want to keep you around. So this is an overall strategy for workover planning. So the first thing you have to do is identify the problem. Identify that you have a problem and what is the problem. And then you enter the diagnostic phase, figuring out what's causing the problem. Then you want to list, once you figure that out, you have to list all the possible remedies and screen that process, decide which way you want to go, develop your plan, and implement it. And then after you've done the work, again, you're going to review, record the lessons learned so that the next time you do it even better. The screening process, okay, we've identified the problem, now we're looking at the remedial options, okay? And this is, again, where the engineer is really well suited. He does the technical evaluation and the economic evaluation, and he blends that. So he's going to do a cost-benefit analysis, put it all together, conduct a risk analysis, and then try to quantify that and make a quantified risk analysis. Then rank his selections and decide which one he wants to do and take it to the boss for approval. So once you decide on a route, you've got to come up with your workover plan. So you're going to develop a procedure, you're going to select your equipment, and you're going to look at that procedure. And again, after conducting your risk analysis, you're going to see where you're hanging out and build some contingencies into that so that you have an alternate route in case things go south. Then you're going to implement it, again, review the results, and leave your records. This is entitled Preferred Economic Outcome, and so what we have is we're plotting production rate here versus time. We've got a well that produced down to its economic limit, it was shut in for a period of time to conduct a workover, and made a good well. Okay, that's a pretty simplified way to look at it, but that's what we hope to accomplish. And hopefully the results from this work will pay for our recompletion or our workover. Now, in this case, we did the work where we reached our economic limit, so there really is no deferred production. But sometimes we do the work before we reach our economic limit, in which case you'd also have to take into account the deferred production when you're conducting your full-scale economics. Well, workovers are critical, we know that, but why are they critical? Well, for several reasons. One, we're investing so much money in these. As it says, from thousands to millions of dollars, we have, we're spending a tremendous amount of our CapEx budget on workovers, so it's very important that overall we have a successful workover program. We're taking assets, producing wells that are generating revenue, and then we're doing work on them. So when we do that, again, if we shut in a producing well, we're impacting that existing revenue stream, deferring production to a later date, and so that's going to impact our division's profits during that time. Well control, that certainly is a risk with a workover. Potential for impairment, again, if you take an existing well and work on it, you're risking, there is a chance that you might damage that well, or even worse, that you might junk it. And so there is that risk for impairment with the producing wells that we have to consider. Generally speaking, workovers are a more complex process than completions because we have to find the problem, identify what it is, what's causing the problem, overcome it, and then oftentimes follow that with another completion. All sorts of risks associated with that work. And also, there are a number of possibilities in terms of approaches that we can use to conduct the work, to solve the problem. So it's oftentimes very gray as far as the best route to go. This says benefits may be difficult to quantify. Yes, sometimes it's very clear-cut. Something was very, economical, or maybe it was a complete bust. But oftentimes you hear people say, well, it was an operational success, but an economic failure. What they're saying is they achieved the outcome, they solved the problem, but maybe they spent a lot more money than they anticipated, maybe 2 or 3 times. So it really didn't end up making money, but they did get the casing squeezed, the leak solved, etc. So again, they oftentimes are difficult to quantify. One of the things we have to do with workovers is match the problem to the source. So if I've got a well with reduced deliverability, what is causing it? That's the first question. Well, you have a whole list of things that could be causing your problem. This is just some of them. Reduced reservoir pressure, increased flow line causing an increased back pressure on your well. Increased water cut, that's going to affect your relative perm. You could lead to an emulsion, and having increased water cut is going to increase your fluid density overall and create more back pressure as well. You could have plugging problems, either at the formation, perforation, or tubular level. And there's a lot of things that aren't listed on here as well that could be possible causes. So you've got to figure out what is causing your reduced deliverability. Well, hypothetically, let's say it was increased water cut. Well, what are my options? Well, here we've listed 7 possible options, and so reduced rate as a possible remedy, choke my well back to reduce coning, isolate some perforations that are contributing water, or isolate in the formation, maybe squeeze them off, install artificial lift and try to lift more fluid, Or heaven forbid, we might have to sidetrack or drill a new well, or worst case scenario, abandon our well. Which of these is going to be the most successful? Which is going to be the most cost effective? These are the decisions you have to make as an engineer. How do you know how to do that? How do you know which is going to be the best method? Well, you're going to look at well files, you're going to look at records, see what's been done to this well in the past, look at surrounding wells, what has been done in this field or in this area in general. You're going to talk to your workmates, you're going to talk to your boss, you're going to talk to the field people, you're going to investigate. And with experience, you'll get better and better at this. So if we're going to do a workover, the question that comes up is, what type of rig should I use? Well, in some parts of the world, the question is, should I use a drilling rig or a completion rig, a workover rig? Well, normally for our recompletions, workovers, completions, we want to use a workover rig. Those crews are trained to work with tubing-sized tubulars. They do this work every day. They're going to do you a better job. They're going to perform it more efficiently, and they're not going to tear your equipment up. But in North America, the question more likely is, can I use a conventional rig, or do I need a coiled tubing rig to perform the work? In the past, onshore North America, when we did workovers, we worked daylight hours, unless it was unusual conditions. What type of rig do you need? Well, that depends on how deep you're going to be working. When we rate our workover rigs, we talk in terms of load capacity, braking capacity, derrick size, and the horsepower of our draw works. Well, all these are based upon the assumption that we've got 2 7/8 tubing. So if you have 2 3/8 tubing, you may be able to work a little deeper than the rig is rated for. Or if you're using 3.5-inch tubing, you will not be able to go as deep as the rig is rated for. But you need to size your rig for your particular well that you're going to be working on. That ends our section today. I hope you've enjoyed it. I hope you've enjoyed this Petroscales series on completions and workovers. Personally, I look forward to seeing you in a Petroscales class soon. Thank you.